So, mathematical methods in physics, part 3, practice final exam, picking up here with number 5. Solve the heat equation here. This partial derivative of u with respect to T equals D times second partial derivative of u with respect to x on the interval from 0 is less than x is less than L. And here we have subject to u of 0 comma t equals 0 and partial derivative of u with respect to x of this L comma t equals 0. Initial condition, u of x0 equals a sine of 3 pi x over 2L. So part A, separate the variables. Part B, solve the eigenvalue problem. Part C, construct general expansion. Part D, determine the exact time evolution. And Part E, analyze long time asymptotics. So this is partial differential equation. So we can write this u sub t equals d u sub xx. For 0 is less than x is less than L, and u of 0 comma t equals 0, u sub x of L comma t equals 0. So u is going to equal x of x, t of t, x t prime equals d, x double prime t. So let me read that again. X t prime equals d, x double prime t. So t prime over dt equals x double prime over x equals negative k squared. So t of t equals e to the capital negative d k squared t. And x double prime plus k squared x equals 0. So the spatial solution is x equals a sine of kx plus b cosine of kx. And our condition here, x of 0 equals 0, gives b equal to 0. And our condition here, x prime of L equals 0, gives ak cosine of KL equals 0. Building on that, for non-trivial a, cosine of KL equals 0. So KL equals quantity 2n plus 1 pi over 2. N equals 0, 1, 2, on and on and on. So k sub n equals quantity 2n plus 1 pi over 2L. So the eigenfunctions here are going to be x of n of x, that equals sine of this quantity 2n plus 1 pi x over 2L. And solving for this, the general solution is u of x comma t equals the sum from n equals 0 to infinity, a sub n sine of this quantity 2n plus 1 pi x over 2L times e to the negative d times that 2n plus 1 pi over 2L squared times t. So the initial condition is already a single eigenmode. And this, by the way, this is e raised to this whole exponent here from negative d to t. So the initial condition is already a single eigenmode, and u of x comma 0 equals a sine of 3 pi x over 2L. And this corresponds then equals 1. So u of x comma t equals a sine of 3 pi x over 2L e to the negative d times that quantity 3 pi over 2L squared t. So our long time behavior u of xt, that's approaching 0 exponentially as t approaches infinity. Okay, that's number 5. Moving along to number 6. Okay, so number 6, we have a tensor t sub ij equals x sub I, x sub j minus r squared delta sub ij. Apologies for that delta in three-dimensional Euclidean space. Part A, show that tensor, show tensor sub ij transforms as a rank 2 tensor. That's part A. Part B, compute its trace. Part C, determine the eigenvalues. Part D, show whether it is traceless. Part E, compute del sub I tensor sub ij using Einstein's summation convention. And part F, determine whether the tensor is isotropic. So this is a tensor analysis problem. Okay, so here we have this tensor sub ij equals x sub I, x sub j minus r squared delta sub ij. R squared equals x sub k, x sub k. Because x sub I transforms as a vector and delta sub ij is invariant under rotations, we could say x sub I, x sub j, and r squared delta sub ij both transform as rank 2 tensors. So therefore, that tensor sub ij, their tensor t sub ij is a rank 2 tensor. Our trace here, t sub ii, that tensor t sub ii equals x sub I minus r squared delta sub ii. And since x sub I equals r squared, delta sub ii equals 3, then that tensor sub ii equals tensor t sub ii equals r squared minus 3r squared, which is negative 2r squared. So the trace of t is negative 2r squared. So we could conclude that that tensor t sub ij is not traceless. To find the eigenvalues, t sub ij, t sub j, that equals x sub I, x sub j minus r squared delta sub I, j, x sub j, and that equals x sub I r squared minus r squared x sub I, which just comes out equal to 0. So the radial eigenvalue happens to be 0. For any vector v sub j perpendicular to x sub j, v sub j, x sub j, v sub j has to equal 0. Then from there, t sub I, tensor t sub ij, v sub j equals x sub I times that quantity x sub I, v sub j minus r squared v sub I equals negative r squared v sub I. So the two transverse eigenvalues happen to be negative r squared and r squared. So the eigenvalues come out to be 0, negative r squared, and r squared. Okay, building on that, we want to find the divergence here. Find divergence, we have that del operator sub I tensor t sub ij, that equals this whole expression here. Rewriting this here for these partials. We get these partials here, relations to the tensors. So just writing all of this out is a bit tedious. We wind up with this del operator sub I tensor t sub ij equals 2x sub j. So what happens is the tensor depends on the direction of x sub I. So it is not isotropic. An isotropic rank 2 tensor must be proportional but to the following, but this contains this x sub I, x sub j. So this tensor t sub I sub j is not isotropic. Okay, sorry about that I had to go through that pretty quickly. Something came up. Sorry about that. But this is part 2. Thank you very much and have a great day.